Welcome to the Math Record. Today I'll be covering the ICTM State 2017 Division AA Algebra 2, which I'll be answering questions 9 and 15 in this video, and then questions 17 and 19 in the next video. As usual, scroll down all 20 questions, and I'll give the answers at the end. So let's start with number 9. Let x, y, and z, they didn't write in z, represent positive integers that satisfy the system. Determine the smallest possible value of x plus y plus z. Okay, so what we could do is that we cancel out one variable, so we have two variables. We could try to find out like a pair that works. So let's multiply the first one by 3, so that's 6x plus 9y plus 21z is 3933. And then we can multiply, so if we cancel our x, we can multiply this by 2, so that's 6x plus 4y plus 10z is 3436. So let's subtract the first one by the second one. So that's 5y plus 11z is equal to, so 3933 minus 3436, we get 497. Okay, so now we have to find a value to see if it works. So let's just say y is equal to 5, y is equal to 1, so that's 497 minus 5 times 1, and then divide by 11 to get our z. So that's not an integer, so let's say instead of 1, it's 2. That's not an integer. Let's say it's not 2, it's 3. Okay, let's say it's 4. That doesn't work. 5, 6. So just do this on your calculator so you can just spam which possibility works. Okay, so starting at 7, so when y is 7, z is equal to 42. Okay, so now let's find out what value our x is. So going back to our question, 2x plus 3y plus 7z is 1311. We could plug in our y and z and then get our x. So 1311 minus 3 times 7 minus 7 times 42, and then divide by 2, and we get 498. Okay, so we have this, so we need to check if this is the smallest. So a neat rule about kind of how equations work for multiples, if we look at this one, to get the next multiple that kind of like gets both integers as like how we got for 7 and 42 for y and z, all we have to do is look at the 7, and then whatever the coefficient is for the opposite term, we're going to increase it that by. So 7 we're going to increase by 11, so the next one would be 18, and then this one we're going to decrease by the other one. So we have 42, we minus the 5, and that's 37. So that's going to be the next pair. So we plug it into our first equation again. 1311 minus 3 times 18 minus 7 times 37 divided by 2. We get x is equal to 499. So what just happened here? Well, we look at this, we added 11, right? This one we subtracted 5, and from 498 to 499, we added 1. So overall, we added 1 plus 11 minus a 5. So we actually added a 7, right? Because this is 12 minus 5 is plus 7. So overall, if we keep increasing this pattern, that means this one has a plus 11 again, this minus 1, minus 5, and this will be another plus 1. So this will add another 7. So overall, that means if we're increasing the sum, that's not going to be the smallest. That means the smallest would be our first triplet, which is 498, 7, and 42. So add that together. So we should get an answer of 547. And that's your answer for number 9. Okay, now let's go to question 15. In a bridge game using a standard 52-card deck of 13 cards in each of the 4 suits, each of 4 persons is dealt 13 cards at random. If Jerry is one of these 4 people, determine the probability that Jerry was dealt exactly 4 cards of one suit, exactly 4 cards of a second suit, exactly 3 cards of a third suit, and exactly 2 cards of a remaining suit. Express your answer as a decimal rounded to 4 significance figures. Okay, so basically we need to find out how many combinations he could choose out of 52 cards. He could choose 13. Well, that's simple. That's just 52 choose 13. And we're not going to permutate 13 because it doesn't matter what order that he was given the cards. It only matters what cards he has in his hand. Okay, so it doesn't matter if he got like a jack first and then he got like a queen later, or then he got a queen and then he got a jack. It doesn't matter. So we're going to use choose, so which is combinations. So we're going to do the same thing for the suits. So determine the probability that Jerry was dealt exactly 4 cards of one suit. So one suit is 13 cards. So 13, choose 4 of those cards. And then multiply that to exactly 4 cards of a second suit. So 13, choose 4 again. And then third cards of a third suit. So 13, choose 3. And then the last suit, we choose 2 of them. So 13, choose 2. So basically, these would give us the amount of combinations that I could choose from one suit, 4 cards from one suit, 4 cards from another suit, 3 cards from the third suit, and the 2 cards from the last suit. Multiply these all together, and that should give us the amount of combinations that work. Now, this is not it. There's actually still more, and that is going to be 4 factorial over 2 factorial, 1 factorial, 1 factorial. Oops, that's kind of hard to tell. So 1 factorial and 1 factorial. And the reason this is important is because there's 4 suits, so 1, 2, 3, 4. So those 4 suits, so 4 factorial ways to choose those 4 because they didn't specify which suit it is. So this 4 could either be a spade, a diamond, a clubs, a heart, and the other ones could be flipped in different orders. So it doesn't. So we need to find a way to find those amount of possibilities, and you could do it this way, which is 4 factorial. And since 2 suits are choosing 4, that means there's 2 of them, so 2 factorial. There's 1 suit that is 3 because you're choosing 3 cards, and then 1 suit that's choosing 2. And that's all you have to do. That's just the idea of using combinations. I mean, ordering with the same groups because there's 2 groups of 4, 1 group of 3, and 1 group of 2. And now we can multiply these all together. So these numbers is going to get super big, so I just recommend you doing on your calculator. So combinations, 13 choose 4, 13 choose 3, 13 choose 2, and then 52 choose 13. So then we have 13 choose 4 times 13 choose 4 times 13 choose 3 times 13 choose 2, and then multiply by 4 factorial over 2 factorial, 1 factorial, 1 factorial. And then we have this entire number divided by 52 choose 13. And we should get a decimal for 4 significant figures is about 0.2155. And that's your answer for number 15. Okay, so that's basically it for those 2 questions. Well, thanks for watching, and I'll see you at the next math record.